Great. So before I start talking about things which are static, things which are functional, and about Ruby, allow me to introduce myself. My name is Stępień. I come from Warsaw, which is around 350 kilometers there. And I divided the talk roughly into two parts. The first one will be more technical, with code on screen. And the second one will be more conceptual, without any code. Both parts will be about languages. And I'm going to make 5 observations throughout the talk. So yeah, I'm very happy to begin the day 2. And without further ado, let's get into it. Ruby. Assuming that Smalltalk did not exist, it's a quintessence of object orientation, right? Most we can get out of an object-oriented language. That's not entirely true. Mats himself repeated many times, Mats, the author of Ruby, he said that his main source of inspiration was, in fact, Lisp. And you see it in the language. Hooray. Basic operations on the array class are a direct copy pasta from Lisp. In fact, some of them are even aliased using the same verbs, to say so. Another example, blocks. We love them. We use them everywhere, don't we? We use them to allocate and release resources when we use them. We use them for filtering, for any kind of loops over collections. The whole RSpec is nothing but huge pile of blocks one into another. So if we define a method, an operator, which means that one language ecosystem, not the language, but the ecosystem surrounding it, inspired another ecosystem, then we can clearly say that Lisp was an inspiration for Ruby. And this is my first observation, that Lisp inspired Ruby. Now, the question is a reverse relation present? Do we have languages which were inspired by Ruby? Surprisingly, yes, we do, and they are not the languages you would expect to see in this context. First example, let's talk about Rack. Rack is a piece of software which you surely know very well. I hope it's visible more or less. It's the interface between web servers running Ruby applications. Here we've got a very simple Rack app which simply returns hello Rack with a given header specifying that it's text plain and error code 200, and then we launch it on port 9292. Now I'm going to modify this code a little bit and tell me whether you see many differences. 3, 2, 1. Has a lot changed? I don't think so. In fact, it's quite similar. The same API, the same principles, same abstraction over HTTP. But the joke is that now we've entered the world of closure. This is pure closure, Lisp for JVM. And well, the formatting is not fully closure. White spaces should be rearranged a bit. This is way better. And as you can see, this is a direct port of Rack. This code uses the ring library, which was heavily inspired by Rack. As you can see, certain concepts which were developed in the Ruby ecosystem fit well. I'll gladly take questions after the talk if I can. Inspired this ecosystem. Second case, RSpec. Let's consider a simple example which checks whether addition of doubles works as expected. Once again, I'm going to modify it subtly. 3, 2, 1. Not that different, isn't it? Well, seemingly. This is pure Haskell. Functional, statically typed, lazily evaluated. That is, everything which Ruby is not language. It's quite the same, right? It uses HSpec library a port of the Ruby concept to the world of Haskell. And it fits well, and it's used, at least from what I've heard from some Haskell people. So the second observation is that solutions which were developed in our community migrated to other ones. And I'd like to underline that my point is not saying that Ruby is so awesome because it inspired so many other languages. That's not my point. However, it's not far from the truth. My point is that there are tools which solve certain problems well in one area. However, when ported to completely other environments, they work equally well. So let's talk about those tools which solve certain problems in other non-Ruby, far away from Ruby ecosystems, and see how they apply to a different environment, to the Ruby world. Let's talk about testing. Let us return to the RSpec example. Let's say we carefully implemented the dividing division division method, just as Tim showed us in case of Topaz Ruby, and we want to test it. This test doesn't give us much. We are just certain that 1.5 divided by 3 yields half, not much. So let's change it, add parametric testing, and cover a whole range of examples. It might be a bit better indeed, but of course there are edge cases, right? And edge cases, of course, you can specify by hand all of them and specify what behavior do you expect. But it's tiresome, isn't it? So let's see what a different approach would look like. We go back to HSpec. We directly rewrite the Ruby example. And now we make a change in the last line. Instead of specifying a concrete input and concrete output, we specify a property which we expect that the tested function will hold. In this case, the property is specified by a lambda. This is a lambda expression, or a block. It takes 2 arguments and returns value of this expression. If we run it, we get a following error. The testing library generated automatic inputs for our function, and I found out that for this input, it dies. Well, that was expected, so let's modify our test a bit. We cannot do anything with division, right? It simply is not predefined for 0. So instead, watch the last line. We introduce a following rule saying that, thank you, we are interested in the result only if b is different than 0. Wonderful. Let's test it again. Another error. The reason? Well, floating point operations aren't precise, are they? If we launch GHCI, it's an Haskell equivalent of IRB. Indeed, it turns out that it's not 3. In fact,
the other way.
Thank you. No? Yes. Perfect. In IRB, it's just the same. So now let's think what happened. If we as software developers, software engineers, assume that floating point division will yield an exact result, we should be fired. And thanks to this library, our job is saved. Quite useful, right? It generates tests for us. We don't have to think about test cases to a certain extent, of course. It's not completely automagical. The name is QuickCheck. It's on the market for over 13 years. And it's been production ready way before Rails went public. And you might think, OK, awesome, but we speak Ruby, right? This isn't quite a Haskell conference, so why should we care? Because our language provides tools which allow us to port this concept and use it in Ruby without any problems. Is there a catch? No, there's not a catch. It's been done already. It's called rush-check. You gem install it. And here's an equivalent. I begin by including a module to make it less verbose. And then I specify a property. Here, I specify that I expect 2 floats on the input. And here they are assigned to variables. And this should be true or test fails. Then I execute the test. I get the following result. Rush-check managed to falsify my assumption with the following input, as expected. So let's introduce a similar change as in the Haskell version. Watch the body of the block. We introduce a guard saying that if y is 0, we're not interested. Keep on generating new inputs. Now, wonderful. It's wrong again because of floating point inaccuracy, right? OK, time for some cold realism at this point. It's a lot of fun to do some weekend testing of simple data structures. However, in 9-to-5 job, that's not quite what we are doing, isn't it? No problem. Rush-check provides API which allows you to specify how you want to generate arbitrary instances of any Ruby objects, be it your active record objects, whatever. Based on its existing generators of test cases, which generates floats and strings, etc., you can generate arbitrary instances. Therefore, I claim that Haskell ecosystem managed to put a bit of its inspiration into our world, and it's good. It creates new options, new possibilities. And this would be third observation, that ideas from Haskell work surprisingly well in our ecosystem. I think that at this point we are quite tired with testing, so let's move to another topic which is quite popular during this conference. Let's talk about concurrency. A topic which was touched already in a very interesting presentation yesterday. Concurrency is a problem which saw various solutions, various approaches. I'm going to talk about one of them, a Swedish one, about Erlang. Erlang is built upon 2 things. Firstly, a rock-solid virtual machine, and secondly, a set of libraries in the standard library of the language. And as long as your problem is more or less related to client-server communication, distribution, peer-to-peer stuff, it's most probably already solved in the standard library. You could argue that Erlang is simply DSL for concurrency. The virtual machine is quite strange, and without it, the whole system would not work at all. In this virtual machine, we have basic operations such as spawning and linking processes, sending and receiving messages. In fact, sending messages was so important that it was renamed to exclamation mark because logical negation was less important. Awesome. So we've got a very powerful virtual machine which allows to have good concurrency. However, in Ruby, our virtual machines are not quite as parallelish as the Erlang one, are they? No problem. We can just port concepts, ideas, not the underlying virtual machine. Once again, it's been already done. However, firstly, allow me to, in case you wonder, all right, but does anyone, in fact, use Erlang? Does it work anywhere? Has any of you played any Call of Duty titles on multiplayer? Hands up. Wonderful. Matchmaking system and the multiplayer is done in Erlang. The backend, which handles multiplayer in Call of Duty, Modern Warfare, all these things, is Erlang. Those of you who have not played Call of Duty titles, do you have Facebook accounts?
No. No way.
Me neither. But I played Call of Duty. Facebook chat. It's Erlang. I hope that this is more convincing and well, it will be a better proof that Erlang is used in production code to solve massively concurrent problems. And ideas upon which it's based has been ported already, and they were introduced during this conference already. Hello, Celluloid. Celluloid takes ideas from the Erlang VM, wraps them with Ruby idioms, and gives us ready objects to say so. Let's take a look at an example. Since Celluloid was already introduced, I can jump straight to my examples. A capital is the main city of a country. In case of Poland, currently, it's Warsaw. However, given the quality of this conference, it might make sense to move capital to Wrocław. Sorry, Kraków. Beforehand, we have to decapitalize Warsaw. So let's write a method for that. Wonderful. Now, we can create a capital, let's name it Warsaw, and decapitalize it. Warsaw is, not surprisingly, disappointed. The process of decapitalizing a capital takes time, takes money, it's expensive. We do not want to do it in the main thread. Let's do it in the background. This will require certain changes. Let's include the magical celluloid module and then introduce an instance variable which will make it easier for us to see that the state of the capital has changed. Apart from that, I'm setting capital to true here and decapitalizing it to false, and Warsaw is still disappointed. Wonderful. We create an instance. This time, you see that it's wrapped in an actor, a celluloid actor. And if we decapitalize it normally, we have the disappointing message. And Warsaw is indeed not a capital any longer. Now let's move it to the background. A subtle change. We add an exclamation mark. Remember Erlang? Exclamation mark was sending. We get nil. Because once we fire a method asynchronously, it's fire and forget. We send a message and we are not interested in the result. We're not interested that Warsaw is disappointed. And still, Warsaw is not a capital any longer. However, Warsaw can be really disappointed. That disappointed that it will raise an exception while being decapitalized. Now, this is a problem, right? If we decapitalize the exception-raising Warsaw without bang, we are hit in the face with the runtime error, as expected. Now, we introduce exclamation mark. The error is thrown in a separate thread. It is logged, and if we don't care, we will never know about it. And we are in our main thread, in which we called the capitalized bang, we get nil, and everything moves forward without any exceptions. We don't care that Warsaw is disappointed. However, from what I saw here, Kraków is a nice city. People are nice. They care. I said Kraków? I meant Wrocław, sorry. Let's introduce certain modifications. This didn't change much. I created a second city, which is also a celluloid actor. And this is where things are getting interesting. We inform that trap exit, the trap exits method informs the runtime environment that once another actor, which is linked to the current actor, dies, this method, specified by this symbol, should be called. Let's see how it works in action. We spawn a capital, we spawn a city, and we link them here together. Now, once we decapitalize asynchronously, we get a runtime error in a separate thread, and in yet another thread, the Wrocław actor is being notified about the exception. Yet in the main thread, nothing happens. We still get the nil value and we carry on. So as we can see, a lot of things from Erlang were ported to Ruby despite lack of underlying solid virtual machine. So this is my fourth observation. Ideas from Erlang work great in Ruby. Let's think for a second. Good news is that this is the end of part 1. No code from now on. I would like to take the opportunity to say that I personally like Kraków a lot, and I like Kraków people a lot, and I seriously encourage you to pay a visit there. Wonderful place. No hard feelings at all. I can only recommend. As a native Warsawian. Let's move to part 2. Let's talk about natural languages. They are fascinating. There's plenty of them. And they express ideas in completely different ways. Człowiek człowiekowi wilkiem. This is a Polish proverb which translates to more or less something like this, verbatimly. The meaning is expression of disappointment that people are mean to each other. Observe that in the Polish version, we use just those 3 words. In fact, in the Polish version, there is no verb at all. You see that the way of expressing thoughts is completely different, right? Noun-oriented, verb-oriented, modifying words or adding small words here and there to modify the meaning. To go further, there is a thing called linguistic relativity. And it says that the language which we speak affects how we think, how we formulate thoughts. And this was introduced for natural languages. However, in a talk delivered in 2003, Matt said that he, as a Japanese speaker, has serious problems when it comes to expressing himself in English. When he's speaking Japanese, he's more polite, more emotional, while in English, he's straight to the point, blunt. And this was his first point. And then he said that this applies to programming languages. He showed examples which prove, according to him, that if you remove natural from here and replace with programming, it works fine as well. Beating the Averages is a very good essay which was published 2 years earlier by Paul Graham. In this essay, he proposed a scale of languages expressiveness. And there was a programming language named Blob, which was that expressive. Programmers who used it were proud of themselves because their language was more expressive than assembler, more expressive than Haskell. Yet, when they looked upwards to the language foo, they didn't understand. Strange syntax, strange constructions, makes no sense at all. Now let's move a bit to the right. The foo programmer is happy because he's proud of his language, which is, in a way, superior to Blob. However, when he looks to the opposite way, foo sharp is a mess. Why do you need all this strange syntax, right? And this essay can be summarized with a following sentence taken from the Pragmatic Programmer. Learn a new language each year. Develop your portfolio. And this is my fifth observation, that polyglots, both in natural and in programming languages, have an advantage because they have a wider perspective. I prepared a short checklist for you. After you return home, please download different programming languages. Python is not a different programming language. Find things which are not obvious, not clear. Then try to understand them. Try to get the point. Why is it there? How it applies? And then try to port it. Understand whether it would be good to port it to Ruby. Then apply it. Apply it in a gem, write a blog post, or at least on Twitter. However, last but not least, send your findings to me. I'd love to know what you think about it. Seriously. I love receiving mail. Apart from offers, you know what I'm talking about. I'd like to end this presentation with a quote which comes from mathematics. However, I think it applies wonderfully to our discipline. Let me read it for you. By relieving the brain of all unnecessary work, a good notation sets it free to concentrate on more advanced problems. I hope that now the topic of my talk is more clear to you. Embrace the static, cherish the functional, remain a Rubist, a better one. That's all I got. Thank you all very much.